Guys, hello friends. So let's say somebody asks you to create a distributed system with 100% consistency and 100% availability. So can you create such a system? Is it possible to create such a system with 100% consistency and 100% availability? CAP theorem says that if a system is distributed, then either you can have consistency or you can have availability, but you cannot have both. Now let's see if this is true or not. It is true, but let's see. So consistency, availability, and partition tolerance. So this is the CAP. Now there is a lot of uh, uh, people think that okay, you can P is also a factor, like you can have CA and not P, which is kind of not correct in the case of distributed system, because distributed system by definition has partition, so you cannot have partition. You cannot do without partition. So one factor is partition. You cannot choose or unchoose partition. Partition is always there. Now you can only choose either C or A. Now let's say we select three of them. Okay, partition is there, so let's create a partition. So we deploy our system software into uh, two servers. They are connected via a network. So this is the partition. Now let's set some rules. What is consistency? So let's say if a user saves one information, X information in node A, the same X information is if user try to get the same information from node B, then user should be able to get X every time. There is no exception for that. And availability is uh, this happens, you know, now let's say availability is this. There is a guarantee that this will happen all the time. It is available all the time, even if there is a one system goes down or there is a issue with the partition. Still, you are going to get both same data from both the systems. Now, now let's say how it works. Now, let's say the system user one saves data one in this. Now, this one will replicate to node B via this network, the partition, uh, uh, w- and it takes some time. It cannot be, it cannot be instantaneous. So if the same user or any other user try to get the same value from this, then what we are saying is we should get one back. Now, uh, why it is not guaranteed is because uh, one is, let's say you you say okay, we will start showing this number one, this data only when both the systems have that data. So that way you can say consistency, you can ensure consistency. So that is something you develop in the system. So you ensure you code like this, that okay, this new value one, for let's say some key will only be shown when this has been replicated to both the systems. Now let's say there is a partition happens, so there's a system, like this network goes down and partition happens. Now these two systems are not connected. So what happens, let's say you save one and it never reach here. Okay, so what this means is this has this does not have that new value. What this means is if user tried, and again, if the both systems are still uh, as record like this, that both systems are still providing the information, then if the user goes to node A, user will get one. But if uh, the user goes to node B and the data is not replicated and partition has happened and the network is, is off, you cannot replicate, you are not able to come, these two nodes are not able to communicate. And in that case, this value the user would not get one again. Maybe it get null or maybe it old version of that value. Now, what this means is, okay, the systems are available, but there is no consistency because partition is, there is a partition between these two nodes. So what this means is we cannot guarantee consistency and availability at the same time. So now let's see, can we guarantee at least one of them? So let's say, uh, let me undo a few things here. So let's say we are going for we are going for consistency, so CP. So in this case, what we are going to do is we are going to write our code or write the software in a way that unless both systems know that they are at the same version of the data, they will not um, share that information. So let's say user writes uh, version 1 data into this system, a version 1 replicated to the another system, and it also becomes 1. So until this has not happened, uh, the systems are not of this value, this version is not available across the nodes. Only when they have replicated, then only they become available. So this is CP. Unless either they will be providing the older version of this data, or if it is totally new data, then it would be a null value. Now let's say availability and partition tolerance. So in this case, what we are saying is as soon as a user saves version 2 of this data, so this user at this point of time, if there is a timeline and there is a very small difference T1 and T2, and this is, let's say, timeline, and T1 is a time when this data was saved here, then there's a millisecond gap, let's say some millisecond gap where this V2 reaches system B. Between this millisecond, if a user comes at this point of time, then the value would be different. Uh, User, if trying to get the value from version A, would get V2, and if it's the same user or any user trying to get data from version B, then in that case it will be having version 1. And only at this point and this point, both the versions, both the nodes A and B will be returning version 2 of the data. Now this is eventual consistency. So system would be consistent eventually, but at any given point of time, system would be available. Data may not be consistent. So we cannot by design, by simple this, thought experiment, we establish that we cannot have a partition, a system which is distributed has a possibility of partitioning. Means this connection between the nodes can have this consistency of the data and availability all the time. Uh, so what if we just wanted to go with CA? Now CA. Now so when you're just going for CA, what you are saying is, okay, my system is not partition tolerant. That also means that, okay, your system is not on network. There is no wire between your systems. That means is everything is on a single machine. There's like either single machine is up or no. Like there is no way you can create a partition uh, uh, where you have deployed your code. So in that case, it is C and A. So that means there is only, let's say, one instance. Now for one instance, this theorem does not make sense because, okay, it is CA, but the idea was initial question which I put was, can you create a distributed system? Why we need distributed system? We want to scale things. Okay, so we want to scale the software so that millions and millions of users can use our software. So if somebody asks you, okay, can you give me a consistent and available system which is distributed and scalable, then you can say no, it is not possible because of CAP theorem. Uh, Now we can, in the next video we will discuss some systems like Redis which are highly available. but has eventual consistency, and see how they reduce that eventual consistency time to less and less. But it is still there, but you can control it to minimal. So impact is minimal, but they are available. So we will discuss in our next video. Thank you guys.